Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 19 from module 3, problem solving. Classwork opening exercise states that in the coordinate plane, it wants us to find the distance between the points using absolute value. So if I come over here, the distance between these two, they're on the same vertical line, okay? So that would be the point 1, 2, 3, 4, 1, 2, 3, 4, 5. So the first thing I'm going to do is label that 4, 5. And this is 1, 2, 3, 4, negative 1, 2, 3. So that's going to be 4, negative 3. So the first thing I did was label the points. Okay. So what the question is saying, find the distance between the points using absolute value. So the distance from here to here, the distance from 0, that is 0, 1, 2, 3, 4, 5, the distance from 0 is absolute value of 5, okay, which equals 5. And then down here we have the absolute value of negative 3. That's a distance of negative 3. And the absolute value of negative 3 is 3. So the total distance is the sum of these two, 5 plus 3, and that is a distance of 8 units. Okay, how do we check this? By simply counting. 1, 2, 3, 4, 5, 6, 7, 8, 8. Use absolute value. If they're on opposite sides or they have opposite signs, add their absolute values. Exploratory challenge. Locate and label 4, 5. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is the point 4, 5. So, and then it says, and for negative 3. 1, 2, 3, 4. 1, 2, 3, 4, negative 3. So I located and labeled those two values. I'm done. Draw the line segment between the end points given on the coordinate plane. Okay. I can't emphasize enough how important it is to draw accurate graphs, straight lines. So whenever you have a graph, you should always, always, always use a ruler. And I'm going to bring this over like so. I'm going to draw a line from there to there. And there is a nice straight line. Okay. It's not sloppy, it's not messy, it's not scribbled, it's not gone over repeatedly, thicker than it should be. Nice, straight, neat line. Okay, so I drew the segment between the endpoints given on the coordinate plane. So that's done. Notice how I'm doing one piece at a time. I don't read the entire question. I do one thing at a time. It just seems easier. How long is the line segment that I drew? And again, we did that up above. These are the same 2 points. This is the process. The absolute value of one, the absolute value of the other. Since they're on opposite sides of the x-axis, their distance from 0, one's positive, one is below. So when we take the distance is always positive. We add the 2. So it's 5 plus 3, which is 8 units. Okay, and number 2 says draw a horizontal line segment starting at 4, negative 3. So that's starting here. That has a length of 9 units. Okay, 1, 2, 3, 4, 5. I'm going off the grid this way, so obviously I have to go this way. Horizontal means flat out like this. It's going to be parallel to the x-axis. So I'm going to draw a horizontal number line starting at 4, 3. So I'm going to bring my ruler back in. Always use a ruler when it says to draw anything except dots. Okay? So I line up my ruler and I have to count over 9. Well, I'm at 4, so the distance from here to here is 4, and then I have to go 1, 2, 3, 4, 5 more to go a distance of 9. Move this out of the way, and there's my point here, and there is my horizontal number line that goes from 4, -3 to -5. That is a length of 9 units, and it says what are the possible coordinates of the other end point of the line segment. There is more than one answer. Okay, one answer is -5, -3. The other answer would be over here somewhere off the grid, and we would have, here we subtracted 9 from 4, but if I add 9 to 4, 4 plus 9 equals 13, -3. Okay, so there's my two answers. Which point did you choose to be the other endpoint in the horizontal segment? And I said that I chose 5, -5, 4. I think that's what it was. Let me go back. -5, -3. -5, -3. Okay, explain how and why you chose this point. The explanation would be count left 9 units, because if I counted right, units, I ran out of graph. I was off the graph. I'll just say I ran out of graph. Okay. All right. Exercise 3, extending lengths of line segments to sides of geometric figures. The two line segments that you have just drawn could be seen as two sides of a rectangle. Given this, the endpoints of the two line segments would be 3 of the vertices of the rectangle. Find the coordinates of the fourth vertex of the rectangle. Explain how you find the coordinates of the fourth vertex using absolute value. So we had one coordinate, which was our original point, and unfortunately we have to keep going back and forth here. So I had the point 4, 5, and 4, -3. So we had 4, 5, 4, -3. And then I counted left 9 from the 4, -3, and I got -5, -3, which came from up here. And now there's one more. Okay. So I'm thinking this didn't change, but 5 to -3 was subtracting 9. That was to go down from the top right corner. So if I started here and I went down, that was from here to here. And then I went left 9 to get me here. So I can do one of two things. I can either count up 8, right? From 5 to -3 is a distance of 8. Let me just make sure here. Yes, it was 8. Okay. Just verifying. So from 4, -3 to -5, -3 was a distance of 9. But from 4, 5 right here down to 4, -3 is a distance of 8, which is a distance of 9. So what I can do is either count left 9 or up 8. And from which points? So this is -5, -3. So I can go up 8, which would be adding 8 to the y and not changing, or to the x and not changing. Is that right? No, that must be right, left. Sorry about that. I was saying it right and I was writing it wrong. So we're not going to change the x, we're going to add 8 to y, and that's going to put us up here. So if I add 8 to -3, I get 5, and this stays negative. So I would, if this was the origin here, I'd go left 5, up 5, and there's my point. I could have also subtracted 9 from the x value. Moving left, right is x. Subtract 9 from the x value of 4, 5. So if I subtracted 9 from this one, then 4 minus 9 is negative 5. 5 minus 0 is 5. And regardless of which way I did it, I got the same point, negative 5. Okay. How do these 4 vertices, how does the 4th vertex that you found relate to each of the consecutive vertices in either direction? Okay. So it is the same y coordinate as our first point, and it is the same x coordinate as our second. Okay, this being the first point, this being the second point. Okay, so it's the same y value of the first, and it's the same x value of this as the second. How does the 4th vertex? Oh, not second. Same x value as the third. Okay, same x value as this one. So third, the first point was here, second point was here, third point was here. Same x value as our third point, same y value as our first. Okay. Draw the remaining sides of the rectangle, which I've roughly shown right here. But if you went back and drew it here, then I'll use purple. That's fine. So I'm going to draw over to here. And there's our point here. And it is the point negative 5, comma 5. So as I said, same y value of our first point, same x value of our third point. Exercise 4 through 6 says this is using lengths of sides of geometric figures to solve problems. 4, using the vertices that you have found in the lengths of the line segments between them, find the perimeter of the rectangle. Okay, so now we have to go back here and look at our rectangle. Well, we know that this is a distance of 9. We already were told that. Right here. And this was a distance of 8. That was from up here. Okay, 8 units. So perimeter is distance around, so it'd be 8 plus 9 plus 8 plus 9. So I go back here. Sorry about the different pages. But 8 plus 9 plus 8 plus 9 equals P for perimeter. 9 plus 8 is 17, plus 8 is 25, plus 9 is 34. So the perimeter equals 34 units. Find the area of the rectangle. Area equals length times width. So area equals 9 times 8. So area equals 72 units. And we have to say square. Area squared. 6. Draw a diagonal segment through the rectangle with opposite vertices for endpoints. What geometric figures are formed by this line segment? What are the areas of each figure? Explain. Now I've got to go back 2 pages. Get my ruler back out. rotate it. Put this right here. Rotate the other side. Slide it up. Okay, so I'll draw the diagonal in red. Here's our diagonal. Okay, there's our diagonal. We have one endpoint at negative 5, 5. We have another endpoint at 4, negative 3. So it's asking what shape this is, and it is a triangle, and this shape is also a triangle. So we cut a rectangle in half and create two triangles. What are the areas of each of these figures? Okay, area of the triangle is 1/2 the length times the width. So the area is 1/2 9 times 8. So the area is 1/2 72, which equals 36 units squared each. And each triangle is congruent. The diagonal of a rectangle bisects into two congruent parts. So they're both 36 units. Now if I go back and look at this, this was 72 square units for the rectangle, and each triangle is 36 plus 36 plus 36, it is 72. Okay, so it says if time allows, line the edge of a piece of paper up to the diagonal in the rectangle, mark the length of the diagonal on the edge of the paper, align your marks horizontally or vertically on the grid, and estimate the length of the diagonal to the nearest integer. Use the estimation to now estimate the perimeter of the triangle. Okay. So what they're really saying is if you took a piece of paper, I can't do that obviously, but I got down to right about here, which is, well, let's use centimeters, it's easier. So 44 millimeters, or is that 45 millimeters, something like that. Okay. So what do we know about that 45 millimeters? I'm going to point something out to you. So if I go like this, 45 is way over here. So it's the diagonal is longer than either side. Okay, so if we approximate how long that is in an integer, okay, we were out to here, approximately right here. So this is 5, 6, 7, 8, 9, 10, 11, 12, 13. So I would say that the diagonal is approximately 13. Okay. I just paused the video because I wanted to check the calculation. It's close. It's within 1. It's a little more, but that's okay. That was an approximation. So then it says use that estimation to show the perimeter of the triangle. So the perimeter of a triangle equals side plus side plus side. And the perimeter of the triangle was 8 by 9. And then if I estimated the diagonal to be 13, then the perimeter of the triangle is 17 plus 13, which is 30 units. Okay. Okay, the next exercise says to construct a rectangle in the coordinate plane that satisfies each of the criteria below. Identify the coordinates of each vertex. Okay, so I brought my ruler in, so I'm going to have to draw straight lines. Each of the vertices lies in a different quadrant. Okay, so they're not telling us where to put it. They're just saying each one lies in a different quadrant. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is it's picking up my ruler and it won't let me draw up here. There we go. And this is quadrant 4. So what they're saying is we want a point in this quadrant, we want a point in this quadrant, we want a point in this quadrant, and we want a point in this quadrant. They have to make a rectangle, so these two have to have the same x value, these two have to have the same x value, these two have to have the same y value, and these have to have the same y y value. So there's my vertices. I just threw them down there for now to explain, and I may have to look them out. Its sides are either vertical or horizontal, so that's what they were just telling me. The perimeter of the rectangle is 28 units. Okay, so perimeter is 28, so that'd be 2L plus 2W equals 28, right? Because these two lengths plus these two widths, which are equal. So if I want to just solve for a length or a width, then I'd divide both sides by 2, and I'd get L plus W has to equal 14. So if I have this side, let's count as I draw, how far is this? 1, 2, my ruler's not behind there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let me move that out of the way. So this is the point 1, 2, 3, 4, and this is the point 3. So this is 4, 3. And this is negative 5, 3. Which makes a distance of 9. And it said the perimeter of the rectangle is 28. So if that is 9, and this is 9, okay, that's 18. That leaves me with 10, so that leaves me with sides of lengths of 5. Okay, and believe it or not, I just guessed this when I put it on there, and it actually is going to work for their parameters. That does not ever happen. So I'll do my sides in red, right here, and right here. So this is 1, 2, 3, 4, 5. So this is a length of 5, and this is a length of 5. 9 plus 5 is 14. 9 plus 5 is 14, totaling 28. Okay? Using absolute values, show how the lengths of the sides of your rectangle provide a perimeter of 28. Okay, so what they're saying is the absolute value of negative 5 equals 5. That's this right here. The absolute value of 4 equals 4. One was negative, one was positive, so 5 plus 4 equals 9. That's this. This will be the same because this is the point negative 5 comma negative 2. And this is the point 4 comma negative 2. Okay, so this side was 9. And then if I do this side or this side, then I can take the absolute value of what's different. 4 and 4 is equal, so the difference of 3 and negative 2. So for the other one, I'm going to do the absolute value of 3 equals, that's messy, equals 3. And the absolute value of negative 2 equals 2. Since they're on opposite sides, we have to add. 3 plus 2 equals 5. So I got this, the length 9, the width 5, and now 9 plus 5 is 14. 9 plus 5 is 14 on the opposite sides because they're equal, and that will give me a perimeter of 20 feet. That is the end of lesson 19. Go do your problem set.